Okay, so in this worksheet called Multiple Functions Practice, we are going to be modeling circular motion using both sine and cosine functions. So recall that for a parent cosine function, which is what we talked about today in class, the parent function starts at 0, 1, so we're starting at a relative maximum. So if we want to model a cosine graph, we need to make sure we start at a relative maximum or a relative minimum. And then if you recall from our lesson on parent sine functions always start at a point on the center line. So once you identify the center line, you can model any point on the center line for sine. So let's look at the first one. So it's easiest probably to identify your center line first. And in this case, if we look at our maximum, it happens at 2, and our minimum happens at negative, looks like negative 4. Sorry, it's a little confusing. It's negative 4.5. So that would mean that our center line is at y equals negative 1. So our d value is going to be a shift down 1 unit. Our amplitude, if we look at from negative 1 up to our maximum or minimum, is a distance of 3 units. So a equals 3. So now if I go through and highlight either a sine wave or a cosine wave, if I start with a sine wave, I would need to start at any point on the center line and go through 5 key points. That would represent a sine wave starting at the point, looks like positive 2 comma negative 1. Or I could choose to do model with a cosine wave, where maybe if I choose to start up at this relative maximum and go through 5 key points, would bring me back right here. So that would be starting at, it looks like 3.5 comma 2. So again, as long as you're starting at a max or min for cosine, you're good. As long as you're starting with a point on the center line, you're good for sine. So in this case, let's start with what I highlighted in orange. Because I started 2 units to the right, my function would have to be, in this case, that's sine, and I'm starting at a point going up, so I don't need any reflection over my a value, so it would just be 3 sine of, I have to calculate my period, and then my frequency. So in this case, going from 2 all the way through my critical points to 8 tells me that the period ends up being 6. So that tells me that my b value would just be 360 divided by 6, which ends up being 60. So my frequency here would just be 60, and then notice since my x-axis is measured in time, I'm using t as my independent variable, and I need to shift that 2 to the right for my phase shift, and then I need to subtract 1 to shift the entire function down 1 unit. So that would be for sine. For cosine, since I'm starting up at a maximum, I do not need a reflection over the x-axis, so I'm still going to start with positive 3 cosine. My frequency would stay the same, and in this case I'm shifting 3.5 to the right, minus 1. So I'll let you guys choose to do any other point phase shift. If you want to start somewhere in the center line, you'll be using sine. If you want to start somewhere at a relative extrema, you'll be using cosine to do the third example. The next example, let's start by identifying our center line, which in this case our maximum happens at 4 and our minimum happens at 0, so our center line would be at y equals 2. Our a value, the distance from the center line up to a maximum or minimum, 2 all the way up to 4 is an a value of 2. And if I were to go through and highlight 2 different sine wave or cosine waves, maybe I will choose to start right at 1 comma 2 and go through 5 key points. That will bring me to 9 comma 2. So going from 1 to 9 tells me that the period is equal to 8. So my b value, 360 divided by 8, ends up being 45. So for a sine function, I do not need a reflection over the x-axis since I'm going up from that point on the center line, would be 2 sine of 45, t minus 1, because I'm shifting 1 to the right from where it is in the parent function, plus 2, since I'm shifting the center line up 2, which in the parent function is usually at the x-axis. Now if I choose to highlight a cosine graph, I could start up at this relative maximum and go through my 5 critical points. Cosine graphs almost make like a smiley face, like a from peak to peak there, if that helps you at all. That would be a shift 3 to the right, so that's 3 comma 4 is where I'm starting. So that would mean, because I'm starting at a maximum, I do not need a reflection, so that would be 2 cosine of 45 t minus 3 plus 2. And again, I'll leave the last one for you to decide if you want to start from a sine and do a reflection down, if you want to start from a cosine and do a reflection as well. Number 3, if we identify our center line, our maximum's at 4, our minimum looks like it's at negative 2, so that would mean that our center line would be at 1. So we're in vertical shift up 1 unit. Our A value going from positive 1 up to positive 4 is a distance of 3 units. Let's highlight a sine wave and a cosine wave to recognize our period and frequency. So for cosine, I'll start at this point at 4 comma 1. Apologize, the points are kind of hard to see. And since I'm going from 16, subtracting 4, that tells me that the period is 12. So my B value would just be 360 divided by the period, and that's where I get 30 from. So for a sine graph, again, I'm starting at a point. I keep choosing points on the center line going up, so I do not need a reflection. My A value is 3. My B value is 30, and I'm shifting 4 to the right. So it would be t minus 4. Oops, t minus 4, and then up 1, so plus 1. Messing up all over the place here. Sorry, I should have a second parenthesis here and then a plus 1. That's kind of hard to see. Let me just write it again one more time. A little bit easier. Okay, and then for cosine, I'm starting, in this case, maybe I'll start at a maximum again. So that looks like that's the point 5 comma 4. Going through my 5 key points brings me up to 17. So again, you still get the period of 12. So my A value is still positive 3 cosine of 30 t minus 5, since I'm shifting 5 to the right. Oh, you know what? That actually is 7. Oh boy. Starting to mess up a lot here. Sorry, guys. So 3 cosine 30 t minus 7. 1, 2, 3, 4, 5, 6, 7. Just want to double check. Okay, and then plus 1. So that's the first page. On the second page, again, I'll leave you to try one more on your own, depending if you want to go with cosine or sine. Last page here, number 4. Let's start by identifying our center line. In this case, the center line happens right at the x-axis, so it's at y equals 0, so there is no vertical shift. Our A value, if I go from a distance from the center line down to a minimum, in this case I'll do, or a maximum, goes down to -1, so our A value is 1 unit. Our B value, if we were to highlight a period, in this case maybe I'll do a sine going down. So if I start at 90 comma 0 and go through 5 key points, that brings me to 220. So 220 minus 90 gives you, that's not 220, that is 270, right? So 270 minus 90, right, because we're going by 15s. So 40 plus 30, yeah, that's 270. Okay, so our period here would be 180, right? Because I get 270 minus 90 is 180. So that means that my B value is 360 divided by 180. I get 2 for my B value. So I chose to start with a sine function. I need a negative in front of my A value because I'm going down. A value is just 1, so it's just going to be negative sine of 2, parentheses. Notice now my x-axis is in terms of degrees, so I'm going to be using theta minus 90 and then I don't need anything after that because there's no vertical shift. Finally, for cosine, if I want to start, let me start at a relative minimum as well here and go through those 5 key points. I'm starting at, looks like 135, comma, -1. So in that case, again, I started at a relative minimum. I need a negative in front of my trig ratio or trig function here. So in this case, cosine 2 theta minus 135. I'll leave the last one for you to decide on your own. Number 5, my center line, if I look at the max and the min and divide it by 2, happens to be at 1. If I were to look at the amplitude here, going from 1 up to 3 is a distance of 2 units. Going through my 5 critical points for sine, let's start right at this first point on the center line. Looks like we're going by 15 degrees here, so that's a shift 15 to the right. So that's at 15, comma 1. Going through my 5 critical points. So that would, let's see, if we're going from 120 plus 15, that brings us to 135 minus 15. That tells us that the period is 120. So my frequency, 360 divided by 120, ends up being 3. So to model a sine graph, we're going to be using a negative in front of our amplitude because we're going down, so it would be -2 sine of 3, parentheses, theta minus 15, since we're shifting 15 to the right, plus 1. For cosine, let's pick something a little bit farther out, maybe at 165 we'll go from, comma -1. Again, this is just up to you, for you to decide where to go. So in this case, since we're starting at minimum, I need a negative in front of my cosine. 3 theta, in this case I shifted 165 degrees to the right, plus 1. Leave the third one for you to do on your own. One more example. In this case, our center line happens to be at, looks like that is 2, -2, right? Our A value, if we go from -2 up to 0.5, ends up being 1.5 a distance of. If I decide to model with a sine function, maybe I'll go 45 degrees to the right. That would be right here. That brings me from 45 over to 135, so that tells me that the period is 90. So my frequency would just be 360 divided by 90, which is 4. And again, how I got 90 is I went from 135, subtracted 45, and that gives me 90. So for sine, which I'll do in red here, I do need a negative in front of my A value since it's reflected. My amplitude is 1.5, so -1.5 sine of my frequency is 4 times theta minus 45 minus 2. And then finally for cosine, let's start at, what's an easy one to see? Let's go from here. This would end up being, if I divide it by 4, that would end up being 202.5, comma -0.5. Again, this is a harder one to model with cosine. If you had the choice, I would definitely go with sine, but we definitely can still do it. So here for cosine, we're starting at a maximum. I do not need a reflection, so 1.5 cosine of 4 theta minus 202.5 minus 2. And then you could leave the last one to do on your own. And really, these are just sample answers. I really could have started at any key point. And then if I started somewhere on the center line, I have to make sure I use sine. If I started at a relative max or min, I have to make sure I use cosine.